So class 11, today we are discussing about vector, the chapter vector. It is starting now. Here, as you know, that physical quantity, I think preliminary all those things you know what is physical quantity. Now physical quantity, as you know, physical quantity, the physical quantity is of two type. One is scalar quantity, another vector quantity. Scalar quantity, some examples are volume, density, temperature, etc. Vector quantity, force, acceleration, velocity, etc. Now scalar quantity, what is scalar quantity? Now which has magnitude as well. Scalar quantity which has magnitude only. The physical quantity which has magnitude only, that is said scalar quantity. Now vector quantity, which need the physical quantities which need both magnitude and direction for its description, for its complete description. One thing more, only that is not enough for vector quantity to explain. Here it is, and which are added according to triangle law or parallelogram law of vector addition, which follows vector addition rule. So this is vector quantity. Now, so what is vector quantity? Now, which needs both magnitude and direction to describe that quantity completely, and which are added according to the vector addition rule, not arithmetic rule. According to arithmetic rule, it is not added. Okay, it will be added by, here it is very important to know that this is according to these are added according to the triangle law or parallelogram law of vector addition. That means vector addition rule. Okay, this now the matter is now that how to represent this vector. How to represent vector? The vectors are represented by an arrow. Suppose with but this vector is represented by an arrow tipped now straight line segment. Here in this, the length of this segment, it gives the magnitude of the vector, and this arrow gives the direction of that vector. Now here in this, vector can be represented by, now here it is to say that this, it from where it starts, here it is the arrow, where arrow it is, that is the end point, it is set terminus. End point, it is this point, it is set terminus, and where it starts, that says origin. So vector, it is represented in this way by PQ. Here where it starts, that is origin, and it is represented by two letters with a small arrow above it. First letter is called origin and the last letter terminus or end. First letter, it is origin, and the last letter, it represents terminus. Now, so here PQ, it is a vector in which P is origin and Q is terminus. Now, magnitude of vector, here it is to say that if it is written like this PQ, this vector, this mod, that means magnitude of the vector PQ, and this magnitude of vector, it is represented by PQ. Now here this can also be represented by a single letter. It can also be represented by a single letter. Suppose this PQ vector, suppose it is represented by A, so it will be this A. Okay, now here it is some type of vectors. Okay, some type of vectors. Here it is that equality here it is equality of vectors. Now when two vectors will be said equal, when two vectors A and B when their magnitude are same and they are in the same direction. Two vectors A and B are equal vectors if their magnitude and are equal and the vectors are parallel, that means in the same direction. Suppose that one vector, this A, this is A, one vector, another vector, this B. one vector A, another vector B. These are in the same direction. When it will be same direction, or when these are parallel. So if then two vectors are said to be equal if their magnitudes are same and those are in the same direction, that means those are parallel. Okay, now this is equality vector. Now here it is that suppose some examples are there. Suppose this A vector, it is there, and B, A vector and B vector excuse me, here this A vector and B vector, they are parallel and their magnitudes are same. Magnitude same means their length are same, because length of that vector, length of that line segment gives the magnitude of the vector. So here this A and B, these are parallel and their magnitudes are same, so these are equal vectors. So here this OA and O dash A dash, OA and O dash A dash, these are equal vectors. Okay, now next it is there that opposite vectors. These opposite vectors, if their magnitudes are same but they are in opposite direction. Suppose this B vector and this C vector, these are in opposite direction. Their magnitudes are same, length of these segments are equal, so these are opposite vectors. Now this B and C, these are opposite vectors. Now here it is, next it is there that collinear vectors. Collinear vectors, if parallel vectors, whatever be their magnitude, or collinear vector, here it will be that parallel vectors. Parallel vectors, these are collinear. Parallel vectors, these are collinear, whatever their magnitude. So those are these are collinear vectors. Now next it is there that co-initial vector. Co-initial vector, if those are starting from the same point, that means their origin is same. If some vectors whose origin is same, this OA vector, OB vector, OC vector, those are starting from this point or same point, so these are said co-initial vector or concurrent vector. Now these vectors may be in the same plane or these may be in different planes. Okay, so this is co-initial vector. Now next it is vectors in 3 dimensions. Vectors in 3 dimensions. Here these vectors in 3-dimensional space, if the vector it is in 3-dimensional space, then that is said 3-dimensional vector. Here in this, see that this is a cube. Here this is a cube. Now then diagonal, the largest diagonal, the biggest diagonal. So this FC, this will be 3-dimensional vector. Okay, biggest diagonal, one vertex to opposite vertex in the opposite face. So this that means, or it can simply, it can be said that largest diagonal, that will be a 3-dimensional vector. Okay, in 3-dimensional space, if a vector is there, so that is said that three-dimensional vector. Now next it is there that composition or addition of vectors. As it has been told that vectors cannot be added by simple arithmetic method. Vectors cannot be added by simple arithmetic method. For this some special rules are there, which is said that vector addition rule. So they are added by more complicated method. What are those? One, it is triangle law of vector addition. Another, it is parallelogram law of vector addition. One, triangle law of vector addition. Another is parallelogram law of vector addition. Here suppose that this OA is one vector, AB is one vector. This OA, it is one vector from, and AB, it is a vector. Here from the here suppose that one person is going from O to A, and then from here he turns and he goes from A to B. Then his displacement, that will be equal to OB. So this OB, it will be said displacement vector. Here in this, that here this by vector method OA, this OA OA vector plus AB vector will be given OB vector. This OB vector, this is the resultant vector. Now, but it is to remember that magnitude and direction of here in this, it will be said that this OB is not equal to, magnitude of OB is not equal to the sum of the magnitudes of OA and AB. So this is that magnitude of OB is not equal to magnitude of OA and magnitude of AB. Now here, so here it is that here this addition or composition of vector, how it can be defined, that two or more vectors can be added to give a single vector which gives the same result. Okay, two vectors can be added to give a single vector which is called the resultant of the two vectors and which produce the same effect as that of the original vectors together. As means the result which produces same effect as that by the given original vectors. So this is said composition of vectors, and the vectors which are added, those are said components. Okay, now here, so what is two or more vectors, what is addition of vector? Two or more vectors can be added to give a single vector which is called resultant of the two vectors and which produce the same effect as that by the original vectors together. Now, the process of finding the resultant is called combination or composition. Process of finding the resultant is called combination or composition or addition of vectors. Combination, composition or addition of vectors, and those from which those are added, those are said component. Now here it is, you remember that this magnitude of resultant is not in general equal to the sum of the magnitudes of the component vectors. Magnitude of resultant is not in general equal to the sum of the magnitudes of the component vectors. Here you see that this OA is a vector, AB is a vector, OA plus AB is equal to OB. This is resultant. Now this OB, so it is not so that magnitude of OA and magnitude of AB, it will be added and then you will get resultant magnitude, that is no. Okay, now there are two laws of vector addition. One, it is triangle law of vector addition. One, it is triangle law of vector addition. Another is parallelogram law of vector addition. Now here it is two vectors here in this, when it will be said that this follows triangle law of vector. What is triangle law of vector addition? Now, if two vectors are represented in magnitude and direction by the two sides of a triangle taken in the same order. If two vectors are represented in magnitude and direction by two sides of a triangle taken in same order. Suppose this is a triangle OA, it is OA, this P vector is represented by OA, Q vector is represented by AB. Here it is, if two vectors P and Q, these are represented by two sides of a triangle, then the resultant will be represented in magnitude and direction by the third side of the triangle in the reverse order. In the same order, this P is in this direction, Q is in this direction, in the same order. These two vectors represent two sides of a triangle. Then these are this. Then the resultant will be represented by the third side taken in the reverse order. Here reverse order. So here it is OB, it will be the resultant. So R, it is a resultant. Here these two vector, then P and Q, this, and here it is to remember that from the terminus of the first one, the second vector, it will be started. From the terminus of the first vector, second vector will be started, and origin of the first vector and terminus of the second vector, that will be joined by a line, and that will be the resultant. Okay, origin of the first vector and the terminus of the second vector, that will be joined by a line. Okay, so that will give the resultant vector. So this R joins O, origin of the first vector, and B the terminus of the second vector. So OB, it is a resultant. Now here how to prove, then it is proof. How to prove? The proof is same as parallelogram law of vector addition. Here in this, for this though, we will discuss the parallelogram law of vector addition. From B, draw perpendicular on this. From B, perpendicular, draw on the produced OA. If this is D, okay, so then here in this you will do, you will have to complete one parallelogram like this. You have to complete one parallelogram like this. From O parallel to Q, it will be drawn. If it is C, if it is C, then and then this will be, so then it will be Q and this will be P. Okay, so then similar to parallelogram law of vector addition, this can be proved. Parallelogram law of vector addition, that will be done next day.